Time for some e-learning with Miss Atkins. E-learning with Miss Atkins. E-learning with the puppy. E-learning with Miss Atkins. Yeah. What's up, scholars? Today we're going to talk about condensing logarithms. So taking long expressions of logarithms and making them smaller. We always like things that are smaller, have more information packed in them. So to do that, we're going to use some properties of logarithms. There's a product property and a quotient property. So the product property says if we have a log base b of m times n, that would be the same as the log base b of m plus the log base b of n. So again, we're going to be more interested in combining these that direction, but we can go either way. So we could expand the log, or we could condense the log. Okay, we haven't done this a lot in this class, but we're going to prove where this property comes from. Prove it! Okay, so to do this proof, we're going to start off with, let's say we have b to some exponent, how about b to the L equals m. Now we know that we can change that into a logarithm. We did that last time. That would be log base b of m equals L. Log base b of m equals L. Alright, let's say we have b to the k, and that will equal n. We can change that into a logarithm the same way. Log base b of n equals k. Log base b of n equals k. And then, one more, let's say b to the q, I'm just pulling out all the weird letters right now, is going to be b times L times, b to the L times b times k. Now we know that when we are multiplying things that have the same bases, we can add their exponents. So we're going to say b to the q equals b to the L plus k. Let's slide this up because I'm writing too large. Okay, now these two have the same base. So we're saying b to some number equals b to these numbers added up, which actually means that this q is going to have to equal the L plus k. Alright, that's the only way this works. So q equals L plus k. Alright. And then we also know, because we said b to the L equaled m up here. B to the L equaled this m. And b to the k equaled n. So we also know that b to the q equals m times n, which we can change into a logarithm as well. So it'll be the log base b of n times m equals q. Log base b of m times n equals q. And that's it. Almost here, because we're going to replace a bunch of stuff. We said q equals log base b of mn. Log base b of mn. Plus L was log base b of m plus k, which was log base b of n. That was nice. That was a nice little proof. Cool. So another reason I just went through that is there's an extra credit opportunity for you to prove the next property, the quotient property. If you make a video of yourself proving that quotient property, you will get 5 bonus points in this queue for e-learning. So you'll just
send me a link. I'll put a option in your submission to upload the video, or you can just email it to me directly. Sweet. So anyway, our first property, the property of multiplication of logs. If we have log base b of mn, that's the same as if we had log base b of m plus log base b of n. All right, let's do a couple examples with this property. Okay, our first example, we're going to condense and evaluate the log. So we're going from the expanded version to the smaller version, and then we will evaluate the log. So importantly, our bases all need to be the same of the things that we're adding for us to be able to condense the log. So in this example, we have log base 3 of 27 plus log base 3 of 1/9 plus log base 3 of 3. All of them have a base of 3, which means we can put them all together. And just like our rule says, we're going to just take these numbers and multiply them. So we'll have log base 3 of 27 times 1/9 times 3. So we can, let's see, that becomes 3, that becomes 9, right? 27 times 3 divided by 9. 27 times 3 is 81. Divided by 9 is 9. Perfect, yes. So we get log base 3 of 9 when we condense it. And now we're going to evaluate that. So we're going to figure out what that equals. What does that equal? Switch this back to exponential form. This will say 3 to the x equals 9. 3 to the x power equals 9. Well, we know this. 3 squared equals 9, so x must equal 2. Wonderful, darling. Wonderful. So now we're going to move on to the quotient property of logs. So the quotient property of logs is going to say we have log base b of m divided by n. That's why it's the quotient property, because we have a division situation going on here. Now, if we think about what we had before with the product property, when these numbers were being multiplied, we added the two logs together. Now that these are being divided, we're going to subtract. So this will be the same as log base b of m minus log base b of n. Sweet. That is your quotient property. And again, you'll get some bonus points if you make a video explaining why. Alright. But here, we're just going to do some practice problems. We got the same question saying condense and evaluate the log. So we're going from expanded form to condensed form. Importantly, again, the bases need to be the same for us to be able to condense. And in this question, we have log base 2 of 32 minus log base 2 of 4. They both have a base of 2, so we can condense them. What are we going to do with these numbers? Well, we're going to divide them. So this will become log base 2 of 32 divided by 4. We know that 32 divided by 4 is 8. And now let's see if we can evaluate this log. That equals something. So if we go backwards to exponential form, this will be 2 to the x equals 8. 2 to what power equals 8? And we know that's my favorite number, so we definitely know what power 2 that is. That's 2 to the third. 2 to the third equals 8. So x equals 3. Boom, shakalaka. We've got one more property called the power property. So it's called the power property because our log here is to a power. It's log base b of n to the y. That is equal to if the y was out in front and we just multiplied y by our log base b of n. All right, let's do an example. So here's our example. We're going to condense this log as much as possible. We've got 1/3 times log base 5 of 27. So according to this rule, if we got a number in front, we can make that an exponent here. So that 1/3 is going to go as an exponent to the 27. So this will be log base 5 of 27 to the 1/3 power. We can keep going. What does the 1/3 power mean? Well, that's the same as the cube root. So this is log base 5 of the cubed root of 27. What's the cube root of 27 mean? That means what times itself 3 times equals 27. Well, let's see. We break this down into 3 and 9, and break the 9 into 3 and 3. We've got a group of 3 right here, so the cube root of 27 is 3. So our answer here is log base 5 of 3. Nice. Nicely done. All right, let's put all of these properties together. We're going to do one long equation where we use all 3 of those properties, and we're going to condense this log. So first, let's check, do they all have the same bases so that we can do stuff with them? Yes, they do. They all have a base of 5. Great. Okay. I see we've got a subtraction here. So we're going to need to use the quotient rule between these guys. We've got a number out in front here, so we'll need to use the power rule here. Same with this one. There's a number out in front. We'll need to use the power rule here. And then, all right, we'll use the quotient rule here, and then we've got a plus, which means we'll have to use the product rule. Sweet. Okay, so let's start off. How about we just do the power part first? So we'll make this 4 times log base 5 of a into log base 5 of a to the 4th. Right, that 4 becomes an exponent here. Minus log base 5 of b plus that 2. We go out in front to be log base 5 of c squared. Great. The subtraction sign tells me we got to use the quotient rule. So this is going to become log base 5 of a to the 4th over b. Log base 5 of a to the 4th over b plus log base 5 of c squared. And this plus sign tells me we need to use the product rule. So these will get multiplied. This will become log base 5 of a to the 4th c squared over b. Yes, that's our final answer. Fabulous. All right, scholars, that's it for today. Remember, there's the possible bonus points for making a video of you explaining the proof of the quotient rule. The internet / Khan Academy specifically has a great video for reference. I would recommend it to my peers. All right. I love you guys so much. Come hang out with me in office hours, and I'll see you next time. Peace.